Hey guys, Mrs. Traver here. We're going to walk through our notes on section 9.3. It is solving quadratics graphically. So we just spent sections 9.1 and 9.2 looking at how to graph quadratics. We looked at what A does as well as B and C. And that's kind of where we spent our time. Now we're going to look at something a little bit different with the graph. So it says in the startup, the x-intercepts of a quadratic equation. So that means where it touches the x-axis. They've got several different names that we use. Sometimes they're called zeros. Sometimes they're called solutions. And sometimes they're called roots. So any of these words could represent what the x-intercept is called. And so again, the x-intercept is where the function touches the x-axis. Where the curve touches the x-axis or the line or the function, whatever. So to find an x-intercept, one thing I want you to remember is back when we did lines, x-intercepts. So notice this one, like I've got a few examples here, here. All of those are x-intercepts. All of them are left and right sum amount, so like left sum or right sum, but they're up and down none at all. So to find an x-intercept, we need to set y equal to 0. So we set the height equal to 0. And then quadratics may have 1, 2, or no solutions. And here's a few examples of that. So maybe your quadratic just bumps the x-axis and has one solution. Maybe it goes through it and has 2. Or maybe it doesn't have any solutions at all. It doesn't touch that axis at all. So there's a few options we could get. Let's jump into it. So if we're given a question like this where it says x squared minus 4 equals 0, keep in mind that since we're solving, this originally was x squared minus 4 equals y, and then y is set equal to 0 to find the x-intercepts or solutions. So that y was already set to 0 for us, and we just want to solve for x. So to do this, we're going to graph it and then see exactly where it touches the axis. Later in different sections, we're going to solve for x algebraically. That way we can see the solutions like that. This time we're going to solve for them by graphing it and actually being able to point at it and say, there's the solution. So we're going to graph these just like we did before, and then there'll just be that extra layer of figuring out where that touched the axis. So here's the first one. We've got our A, our B, our C. So our A is 1. Our B is non-existent. There's no x term there hiding. So like there's 0 x's there. So that means B is 0 and C is negative 4. So that makes our axis of symmetry B, remember it's negative B over 2A. So it's negative 0 over 2. It doesn't matter. It's 0. So axis of symmetry is at x equals 0. So that's at the axis right here. I'm going to already color that in so that we know where it's at. All right. Next, we can put that in as the first point of our vertex. So I know that that is the x coordinate of our vertex, and I know that's where I should center myself on that table. So I can look at numbers to the left of 0 at negative 1 and negative 2. And numbers to the right of 0 at 1 and 2. And because our axis of symmetry is through the vertex, when we plug in these points, we'll be able to get like 2 for the price of 1. When I get a point here, it'll copy there. And when I get a point here, it'll copy there. So let's do that. And if it were me, I'd pick to do the positive ones. That way we don't have to deal with the negatives at all. So let's plug in a 1. I'd have 1 squared minus 4. 1 squared is 1 minus 4 is negative 3. That makes that point come over here as well by symmetry. The next one, if I plug in a 2, I'd have 2 squared minus 4. 2 squared is 4, so that's 4 minus 4 is 0. And then if I plug in a 0, I have 0 squared minus 4. That's negative 4. So I've got all my points. I can go ahead and plot them. So let's go ahead and do that. I've got a point at 0, negative 4. That's my vertex. I've got a point at negative 2, 0. Negative 1, negative 3, 1, negative 3, and 2, 0. And then I can connect my curve and extend it out. So our goal here again is to find solutions where the x crosses, or where the curve crosses the axis, and they're right here and right here. So at this spot, x equals 2, and at this spot, x equals -2. So you can see that right from the graph. You can also see that from the table here, when y is 0. So our answer on here is x equals -2 and +2. Let's do another one. On this guy, we've got x squared minus 6 equals 3. First off, this is in kind of a weird format. We're used to it being set equal to y, which we're making 0, but like there's no 0 here, so let's make a 0. Let's get one side emptied out. So let's move this 3 over. So I've got x squared minus 9 equals 0, and now I can see my a, b, and c. So my a is 1. My b again here is non-existent, it's a 0, and my c is -9. From there, let's find our axis of symmetry. It's -b over 2a again, and b again is 0, so my axis of symmetry is x equals 0, right on that y-axis. So I know the first point of my vertex is 0, and it goes right in the middle there. And then we'll do to the left and to the right. All right, let's do our vertex first. I forgot it last time. So if I plug in a 0 to this equation, I've got 0 squared minus 9 is just -9. If I plug in a 1, I've got 1 squared minus 9, that's 1 minus 9, that's -8. If I plug in a 2, I've got 2 squared minus 9, that's 4 minus 9 is -5. And then because of symmetry, I can copy over my -8 and -5. Let's plot our points. -2, -5. -1, -8. 0, -9. 1, -8. 2, -5. So here's my curve. And let's see, we are trying to figure out where we cross the x-axis. It looks to me like it's 3. That's my guess, but we should check. Let's plug in a 3 and see what happens. So I'm going to add a piece to my table here. Let's check 3. If I plugged in a 3, I'd have 3 squared minus 9. That's 9 minus 9. That is 0. So that means -3 was also 0. So I was pretty good at my graph in curving it upwards so that we did have this point here at x equals 3 and at x equals -3 for our two solutions. So my final answer, x equals negative and +3. By the way, we can write this as plus minus 2. I'm going to write it like that this time, plus minus 3. So either that's +3 or -3. That's what that sign is telling us. So there's my answer to number 2. All right, let's try some a different way. This next section says solve each equation by finding square roots. If the equation has no real number solutions, right? No real solutions. So on these ones, we're not going to graph. Instead, we're just going to solve for x. And whatever x equals, that will be where our solutions are because we already set y equal to 0. So, for example, a moment ago, this was like x squared minus 81 equals 0. And then we said, let's just solve for x anyways. So they added 81 to both sides and got where we're at. So we want to get x by itself. And right now it's being squared. So to undo that square, we need to take the square root of both sides. When we do the square root of the left side, the x will be by itself. And on the right side, we have to be a little bit careful that when we square root a number, we need to put a plus or minus with it. So that's important because when we take the square root of 81, we know right off the bat it's going to be 9. But the problem is it could have been more than just 9. 9 times 9 is 81, but -9 times -9 is also 81. So this could have been +9 or -9. And there's our two solutions. So in this case, we did have two solutions, positive and -9. Let's do the next one. We want to get our x squared term by itself first. So let's divide both sides by 64 to move that out of the way. So I've got x squared equals 16 over 64. I know that we can do some simplifying here. What goes into both 16 and 84? I believe 16 does. Let's check. 64 divided by 16. Yeah, 16 times 4 is 64. So this is just 1/4. Okay, so we've got x squared by itself. We want to square root both sides to get rid of it. And when I square root this side, I need to do a plus or minus on that side. So the left is just x squared. I'm sorry, the left is just x. The right is plus or minus the square root of 1/4. Well, we just got done with our radical unit, so hopefully you're feeling confident that you could do this, distribute that radical to top and bottom, and then do a little bit of simplifying. Square root of 1 is 1. Square root of 4 is 2. So we've got plus minus 1 over 2, so x equals positive or negative 1/2. So again, on this one, we had two solutions. Let's try the next one. We want to get our x squared term by itself first. So let's move that 20 over. I'm going to add 20 to both sides. And then let's get rid of the 2. Let's divide both sides by 2. Half of 70 is 35, so 36. And then let's take the square root of both sides. We've got a plus or minus here. So x equals plus or minus square root 36. And that's 6. So there's my answer. And again, two solutions on that one. Last one, let's add 36 to both sides to get that by itself. We've got x squared equals 36 minus 64 should be 42. No, sorry. Struggles are real. Holy cow. Sorry. 80. No, 100. There we go. Holy cow. So that's 100 apart. So yeah, 60 negative. Holy crap. I'm struggling with the mental math here. How about we do 36 minus 64? All right, negative 28. Holy cow. Mrs. Traver, you're killing me. Negative 28. Okay. Next thing I do is take the square root of both sides, which is where an issue comes into play. You can't take the square root of a negative. So there is no solution. So this is one of those situations where this quadratic, x squared equals negative 28, it wasn't going to touch the x-axis. It was one of these type, where it's going to be either above or either below. This one would have been above the x-axis. All right, we are going to call it a day on these notes. I hope they looked good. They were nice and sweet and short.